Unit 4, Lesson 2, Example 3. In this video, I will do the 2-column proof. In the next video, I will do the flow proof. Again, you can choose which video you want to watch for this one, or watch them both anyway. So first thing we're going to do is we're going to annotate our diagram and look at what we're trying to prove. So we want to prove that triangle ABD is congruent to triangle CDB. Okay, and so that's what we're trying to show. And they give us that AB is congruent to CD, so I'm going to annotate my diagram with that information. And they give us that AB is parallel to CD. That is interesting. All right, so to begin our proof, we're going to state our given information, AB congruent to CD, and AB parallel to CD. Why do we know that? It's given. Okay, so here they only gave us one side. Again, our only method that we can use that we know of right now is side angle side. So we have a side. We're looking for another side and an angle that is in between that side. So first thing I notice is that these two triangles share a side. They share BD. And BD is congruent to itself by the reflexive property. Okay, so now I have another side. And in order to use side angle side, I know I need the angle between those two congruent sides, which would be right here and right here. So I haven't used this AB parallel to CD piece yet, which we're going to use right now. So in order to get this angle that I need, that I've put on my diagram, right, they didn't give that to me, I need to show that that is true. And I'm going to label it 1 and 2 for convenience. So they gave me that those lines are parallel, and I noticed that angle 1 and angle 2 are alternate interior angles. And because AB is parallel to CD, the alternate interior angles formed are going to be congruent. So in Unit 2, I had you state first that those were alternate interior angles, and that's based on the definition of alternate interior angles. You can continue to do that if you would like. However, the proofs can get rather lengthy in terms of the statements that you need to make. So I can immediately go to angle 1 is congruent to angle 2. And the reason being is, again, I have two options. I can state alternate interior angle theorem, or I can state what that says, right? If you don't remember which one it is, you have to state what it says, which says when two parallel lines are cut by a transversal, the alternate interior angles formed, angles are congruent. So because I'm given that those lines are parallel, I can say that those alternate interior angles are congruent. So now I have a side, I have an angle in between the second side that I was given, so I have enough information now to prove triangle ABD is congruent to triangle CDB, and that is by side angle side congruency theorem. For part B, this part might be a little bit challenging depending on what you see. So the quickest way, again, a parallelogram, which is this figure that we have here, does not have any lines of reflection that map one triangle onto another. However, it does have a rotational symmetry. So I can say that a rotation centered at the midpoint of BD 180 degrees will map triangle CDB onto triangle ABD. Or I could say something along the lines of this. Personally, I think the first one is a bit quicker. A reflection over, I'm sorry, nope, not a reflection. a rotation about, my word program just crashed, so it's having some issues, about D, 180 degrees, followed by a translation, and again I must state the vector or state the points that it maps to, of D to B. Personally, I think a rotation centered at the midpoint of BD 180 degrees will map triangle CDB onto triangle ABD is much quicker.